Graphing logarithmic functions. So we've graphed logarithms as the inverse of an exponential, where you created a table of values for an exponential, just flip the x and y, now you have the logarithmic function. But that's not always a fun thing to do, especially if the equation is a little bit more complicated. So I'm going to show you how to graph a logarithmic function by only finding 3 very specific points. Now for the equation, this is our generic form of our equation, and I have color-coded it to the best of my ability. You're going to have a number in front of the log. If it's not there, it's a 1. You are going to have a base of the log, and again, if it's not there and it says log, that means that the base is 10. If it says natural log, that means the base is an e. You're going to have a coefficient of the parentheses, everything with the parentheses of an x. And again, if there's nothing there, it's a 1. Inside the parentheses, we need to make sure that it just starts off with x. So this little note here that says that if x has a coefficient, you're going to factor it out to create that c number. We always want x to be by itself in the parentheses. This part looks very much like the quadratic functions formula and the absolute value formula. You're going to have some number being added or subtracted to h, or to x, which is h, and it's always the opposite. And we have some number being added or subtracted. So do not forget, this is always going to be the opposite. So if it says minus, that means h is a plus. If it says plus, that means h is a minus. So always do the opposite of whatever is with x. Your first job is always going to be to state what A, B, C, H, and K are. In your first assignment, this whole process is set up for you. So it'll be a lot easier just to fill things in. However, on the second assignment, you need to create it yourself. This is a generic table of what you're going to do to find your 3 main points. So your 3 main points are called anchor points. And by finding these 3 points, you will be able to graph your logarithmic equation. Now there's kind of some math you have to do with the equation, with the numbers to find your final answer. You're going to start off with these 3 generic numbers. 1, 0, so always starts off with 1, 0 for that particular point. B, 1, so whatever the base of your logarithm is, that's going to go there. And 1 over b, -1. So making it a fraction. If it's a fraction, it just makes it a fraction. We can talk about that. And then you're going to go through these steps. Whatever a is, you are going to multiply the y value by it. So remember x coordinates are x, y, so be careful. You're multiplying the correct thing. You're going to write your new points right there. Then whatever c is, you're going to divide x by it. Now, if c happens to be 1, you don't have to do these steps. If a was 1, you also don't have to do these steps because multiplying or dividing by 1 doesn't change anything. Then you're going to add h to your x value. And again, if it's not there, adding 0, you don't have to do that step. And lastly, you're going to add k to y. So I'm going to go through a couple of problems to show you step by step how this works. But this is the table and all of the information that you need to be able to find your 3 very specific points and be able to graph them. So make sure you have that table and all of this information written down in your notes. Now, one more thing is all of these have an asymptote. It is that line that they will never cross. And it is at x equals h. So whatever h is on your graph, that is the line. You will also be stating the domain. Don't forget it's how far left and right your graph is going. You're going to see some redundancy in that answer. And then your range is how far down and up. Now, my hint for you on the range is that the asymptote is going to do something with your with either your domain or range. So be very careful on that one. Think about what it means to have a line of x equals h. This hint actually should just be over here on the side because one of those is going to be affected by the asymptote. Okay, so here's our first equation. So on this problem, we have that a is 2, so I'm filling this in. B is 3, C is 1, because remember it's the opposite. It's the opposite of this. Sorry, I put that in the wrong spot. C is 1 because there's no number there. H is 1 and K is 4. So if I were to replace these parts on the table, A is 2, C is a 1, H is a 1, and K is a 4. And then over here on the left-hand side, B is a 3, and that means 1 over B is 1 over 3, 1/3. So now I'm going to follow my instructions to find the different answers. So first I'm going to multiply y by 2. So 1 comma 0 times 2 is 0. 3 comma 1 times 2 is 2. 1/3 comma negative 1 times 2 is negative 2. So these are my new points. So you'll see that I'm writing my points as I go. Now I'm going to multiply x by 1. That doesn't change anything. I'm going to skip that step. Multiplying by 1 doesn't do anything. The next step does do something. I'm going to add 1 to x. So that's our first number. So 1 plus 1 is 2, comma 0. 3 plus 1 is 4, comma 2. And 1 plus 1/3 is 1 1/3, comma negative 2. Then I'm going to add 4 to the y values to finish this problem. So that'd be 2 comma 0 plus 4 is 4. 4 comma 2 plus 4 is 6. 1 1/3 comma negative 2 plus 4 is 2. So now I have my final 3 points and I can graph them and create my graph. So I'm going to go over 2, up 4. I'm going to go over 4, 1, 2, 3, 4, up 6, 1, 2, 3, 4, 5, 6, and over 1 and a little up 2. You'll see that these are always in a little bit of a slope. Now if I found my asymptote is x equals h, so that's x equals 1, which means that if I drew a line through 1 on the x-axis, this graph is not going to cross that. So if I wanted to think about the domain, my domain is not going to go any further than 1, so that's going to be a 1, comma, and it is going to go forever to the right, so that's infinity. My range is, it goes forever up and down, so that's just going to be negative infinity, comma, infinity. So there's my asymptote, x equals 1, my domain, my range, and my graph. Okay, let's try another one. On this one, A, I don't have a number up here, therefore it's a 1. B is a 4, that's our base of our log. C, now I do actually need to change this equation a little bit because you'll notice that I have a number in front of x here. And we can only have a number there if it's in front of the parentheses. So I actually need to modify this equation. So this is a 3, which means I need to factor out a 3. If I factor out a 3, I get 3 times x minus 2, and it still says minus 1. So that means that C is a 3. That's the number that is in front of the parentheses. H is a positive 2, and K is a negative 1. So if I fill in my table, A is a 1, C is a 3, H is 2, and K is negative 1. So really you're subtracting 1, not adding, but adding a negative is the same thing. My B term is a 4, my base, and 1 over 4 is 1/4. So now I can start doing all the math to figure out my new answers. So multiplying by 1 doesn't do anything. I'm not going to take the time to fill that in. I'm going to divide x by 3. So 1 divided by 3 is 1/3, comma 0. 4 divided by 3 is 4/3, which I'm going to write, I'll write it as 4/3 right now, comma 1. And remember, dividing something by third is the same as multiplying it by 1/3. So 1/4 times 1/3 is 1/12, comma negative 1. Next thing I'm going to do is I'm going to add 2 to all the x values. So 2 plus a third is 2 1/3. Just going to write that as a mixed number. 4 1/3 was 1 1/3. So if I added 2 to 1 1/3, that's 3 1/3, comma 1. And 2 plus 1/12 is 2 1/12, comma negative 1. Now I'm going to basically subtract 1 from the y value. So my first one is still 2 1/3, comma, 0 minus 1 is negative 1. 3 1/3, comma, 1 minus 1 is 0. And 2 1/12, comma, negative 1 minus 1 is negative 2. So here are my 3 points. I could also say right away that for my asymptote, it's going to be h equals 2. So I'm going to put a line, sorry, x equals 2, at x equals 2. So I know that my graph should not pass that line. So my points are 2 and a little, comma, negative 1. So 2 1/3, comma, negative 1. 3 1/3, so just a little bit more, and 0. And 2 1/12, so 2 and barely past 2 1/12, which is right there. So you can kind of see that it's making this curve right there, and that is going to be the graph of that logarithm. So for the domain, it cannot go as further left than the 2, so it's going to be kind of heading towards the 2, and it's going to go to infinity to the right. And for the range, it's going to be negative infinity, comma, infinity, because we can see it's going down and it's slowly going up also. And so now we have just graphed that logarithm. Now I do want to make one little note. We are not going to finish this problem, but I do want to make a note that if you have a negative sign in front of the x within the parentheses, or there's no parentheses, that needs to be factored out. So you can factor out a negative 1 in that problem to make that x minus 2 minus 8. And now you actually have a c value of negative 1. So be very careful on that. And one other thing, let's just say that the base was actually 1/6. When you're coming up with your points of b, comma, 1 and 1 over b, comma, negative 1, well, if b was 1/6, this first one would be 1/6, comma, 1. But if you already have b in a fraction, this 1 over b, it basically unfractions that, making it 6 over negative 1.